All right, so welcome to Networkers Champ in ICE session, right? So today we're going to discuss about the web authentication, right? Or the guest access in ICE. So need to understand basically. So first we would walk you through the all theory and then the components which is required, right, in this web authentication. There are certain components or architecture of it that we would walk you through to have a proper understanding how basically web authentication works. What all are the prerequisites or what are the important requirements, I would say, that is required in order to authenticate through the web. Okay.
Great.
So
Okay.
basically, first of all, we need to understand what is web authentication. And let me share this screen. I believe you are able to see the PPT, right?
Yes, I do.
Um, just confirm if you are able to.
I can see it.
Okay, cool. So the basically the web authentication. So what exactly it is, right? So this basically is used for the guest access. First of all, right? So the guest access means what? Whatever the devices which are not identified by the eyes or which the devices in your network which are not authenticated or authorized by the eyes, right? But and that should be rejected by that's the default behavior, isn't it? But then
Yeah.
we have to somehow allow them the access. I'm talking about the guest. And guest itself is a very big topic, right? I mean, every company has, regular visitors coming to the companies, getting connected to the network, isn't it? And then we have to also ensure that they're basically the equipment or the device that they are using and plus user, right? That information is completely segregated from my current infrastructure. It should not impact in terms of security, right? In terms of scanning and etc. So web authentication. So authentication in Cisco ISE, it's a method to authenticate users, right? Via a web browser, right? And instead of directly, through 802.1x, like supplicants that we have discussed earlier, right? Like MAB authentication or dot 1x authentication, isn't it?
Yeah.
So basically, it's mainly used for guest access or any device which is, let's say, bring your own device or devices without supplicants, let's say like phones, right? Or printers, IoT devices, right? For them, you have a web access or web authentication. Now, the question is, can you not authenticate phones or the printers, right? Um, through the dot 1x or mx or mab, not definitely through the dot 1x, but then through the map you can still authenticate them, right? The phones and printers we can still
Yeah.
authenticate through the map, but that authentication will take place only when those devices are permanent devices or the users, right, of a company, right? We are completely talking about the guest that they have brought, laptop. Along with laptop, they have brought their personal tablet, mobile phones, and etc. Right? For those
Okay.
certain things, we have this web authentication. Now, when we there are types of web authentication in IIS. Okay, so one is basically the local web authentication, right? And then the second is central web authentication, right? So the central web authentication is a very common in ICE, right? But then we
Mm.
have also local web authentication. What exactly local web authentication is? So local web authentication So here we have switch or WLC, right? Itself acts, the NAT device itself acts as a, the authenticator, right? And then it
Mhm.
hosts the login page, right? So ICE only validates credentials of that device, but then the NAT device, it hosts the login page. It is less feasible, flexible, less used today because it is for small network. Maybe you can still go ahead and use, local web authentication, but then point is when you have already ICE, right? You can have the central web authentication itself. So in case of central web authentication, right? So ICE hosts the login or guest portal page to the guest, right? And then provides advanced other features like, for example, guest self-registration, device onboarding, sponsor approval, branding. So we'll talk about what are they actually. Okay. So by the way, whenever the ICE hosts or generates the guest portal page to the guest user, right? They have certain that can be validated or varianted, I would say, in multiple ways. So when I say multiple ways, or you can say the variants of guest access, right?
Mhm.
So you see here self-registered guest access. What does that self-registered, or guest self-registration is? This basically means the user creates their own account through a self-registration portal, which is generated by the ICE, right? And then they would self-generation portal as in they would put their details, their name, email, phone, and etc. other details, right? So
Yep.
the flow basically is in this self-registration that the user connects to, let's say, Wi-Fi or LAN. Okay, so let me also put it here and take this. So let's say this guest machine, okay, connects to, in this case, since it is wired, so I would talk about wired, but vice versa, wireless or wired. So when user connects basically to Wi-Fi, or LAN, the traffic, it is redirected to ICE guest portal. Okay. Then user fills registration form here. All that forms are because this user would get that web page, the portal where it can go ahead and register. Okay. And finally, an account is created automatically. So as soon as you put all the details and submits, the account is created, right? And then credentials are also delivered via email and SMS. So as soon as you create the account through the web portal, you would get the account details, the credentials via the SMS or email, whatever details or your preferred method is. Okay. Now, why do we call it here? The that's basically called, first of all, the guest self-registration. So now since we have now the credentials and all, you can go ahead and use that credential for further login purpose. Then you have also device onboarding. So that's one guest self-registration. Second one is sponsored guest access also. What? Sponsored guest access. So let me just put it here. Maybe I would just put it in a spawn. So self-registration. Okay. And then the second is sponsored guest access. What basically this sponsored guest access is? So sponsored guest access is basically where the guest account is created, right, or approved by an employee. That basically is called sponsor here. Okay, let's say any authorized person who has been given a role to authenticate, to sponsor, right, a particular account on behalf of this guest user, right? So guest requests access via portal, right? Once it requests access via portal, the employee or the sponsor approves request via email or maybe sponsor portal. They would log into the ICE and go to the sponsor portal and then approve the request. And then finally, ICE issues the credentials like username and password or voucher or any other details, right, to the guest user. Use case could be, let's say, enterprise with the visiting partners, vendors, or clients where IT staff, want a proper control to it, right? Then you have hotspot also, hotspot, right? So what that basically hotspot is, open access, right? So guests are not required to create accounts in this, but then instead, they are redirected to a portal where they just accept the acceptable use policy AUP and click continue. So as soon as they log in, they would get a kind of pop-up or a small page where they have to just check, accept the agreement kind of, and then continue, right? And this is basically they would get the limited access to the network. Let's say airports, coffee shops, retail Wi-Fi. Usually they use this kind of actually hotspot kind of variant, guest access variant. Apart from that, you have this bring your own device, right? Onboarding, which is again guest flow. So bring your own device, right? So in bring your own device, you have kind of a hybrid model where the guest portal is used, right, for the B-wide device registration. And then user is redirected to ICE for the, and then ICE authenticates, it provides the certificates, profiles, and etc. You also have basically, sponsor approval we have discussed, right? So you have also guest self-registered and sponsored, means you would create the account and then finally that account would go to the sponsor and then it will approve. What is sponsor approval? Sponsor approval is basically, let's say a particular guest wants to visit a company, right? So maybe a week before or 4 days before, they send their details to particular company or sponsor. Sponsor on behalf of guest would create the account and send the credentials and the details to the user. So as soon as they connect to the network, they use that credentials or details to get connect to the network, right? So that's basically how the ICE hosts the guest portal page, and then how guest can use that portal page to self registration, or maybe for for account creation and all, right?
Okay.
Now by default, actually, when a guest connects to the network, the guest cannot access anywhere. They cannot access internet. They cannot communicate to other machine. Everything is blocked, right? And this is where there has to be a access list created for particular that guest user where they should not. The only thing that they can do is that their traffic would be only redirected to the ICE. So they would only be allowed to talk to ICE, okay, for the authentication purpose, right? And
Okay.
this is where you would require the ACL, right, on the switch, where blocking everything else, where allowing only the traffic to the ICE. Yeah.
Yep. Sounds good.
Now, so we were talking about here the portals, right? The guest portal page. So there are two things, portal and then URL redirection. What basically the portal is, it is again web-based interface, which is again login page, presented to user or devices when they try to access the network via web authentication. So instead of directly getting network access like map authentication and .1x, the user is redirected to this portal page to authenticate, register, or accept based on what actually variant that we have configured there, right? So again, you have guest portal here we talked about, right? We have bring your own portal, employee own devices, right? You have my device portal, which allows users to manage their own registered devices. Sponsor portal, where used by company employees or managers, which we call it sponsors, to create and manage guest accounts. Yeah. How
Yeah.
basically a portal works in web authentication flow. So let's
Mhm.
take an example here. Let's say user connects to the network, could be any wired or wireless. Access device, okay. So which basically the NAT device switch or WLC. In this case, for the wired, we have switch. For the wireless, we have WLC. Applies a redirect ACL. This redirect ACL, where would you configure? You would configure it on the switch here. Okay,
Okay.
that redirect ACL you would configure in the switch. That
So
forces all
redirect,
STT.
yeah,
Mhm.
sorry, the redirect is configured when for what purpose? For switch and WRC.
Yeah, so that all traffic HTTP or HTTPS traffic should be redirected to the ICE.
Okay, okay, through core switch, right?
Right. Other
Got
thing
it.
I just explained, right, where other things are all blocked.
Yeah.
Then ICE presents the appropriate portal page, right? Like again the guest login. User enters credentials, accept terminal, agreements, register devices and all. ICE then validates the request and sends back the authorization profile. Now you would create the authorization profile, within the ICE that would be basically sent to the access device. Or let's say some of the examples, right? A visitor connects to your corporate Wi-Fi. Instead of internet access, their browser is redirected to guest WebAuth portal, that is basically ICE, right? They log in or self-register. Once successful, ICE updates their session with an access policy. You would create the access policy, like internet only access or how you want basically those guest the accessibility, right? So that's basically how the portal works. Similar to the portal, you have the URL redirect in ICE web authentication, right? So what is URL redirect? It's a process where a user's web traffic, like again, HTTP, HTTPS is intercepted by the access device, which is again NAD, right? And redirected to ICE hosted portal page for authentication or onboarding. So instead of reaching the original website, the browser is sent to the ICE portal, similar to portal itself, right? So URL redirected, the one I just explained, before, basically would redirect your traffic to ICE, where ICE would actually present the portal login page. Now, why URL redirect is needed here? So let's say when a user first connects to the network, ICE does not yet know who they are, right? Then the device is placed in restricted state, means limited access via access list, because we have access list in place. Now to authenticate or register, the user must be redirected to ICE portal, right? So similar example, guest opens browser and tries to go to, let's say, www.google.com. Switch intercepts the and redirects them to ICE to the guest portal and then log in. User logs in, ICE grants internet access, and finally the user is able to access google.com, right? So that's basically now how
Uh,
particular, yeah.
I mean, before you go to this new page, could you go one page behind to the previous one more? Yeah, here once again, yeah, I just missed something in between from example of use cases. Yeah. Um,
Right. Self-explanatory actually.
okay.
When the user visitor connects to a corporate Wi-Fi or the
Open. Yeah.
wired, instead of internet access, they would be redirected to ICE. And ICE would
Okay.
present them the guest portal
Yeah.
to log in or maybe to register, right?
Yeah. Sounds good. Okay. Cool. Because the terminologies are all similar, resemblance. So I'm just, yeah. Okay.
Right, right, right.
So many,
Right.
yeah,
So how URL redirect works basically, this is similar to what we have discussed earlier, right?
with URL,
So
right?
yeah. So
Okay.
user connects by any method, access device, which is NAD, right? Switch or WLC applies a redirect ACL based on ICE policy. This ACL usually allows DNS, DHCP traffic and intercepts, right? The access device redirects HTTP or HTTPS traffic to ICE using the configured redirect URL. Let's say this is kind of the like redirection URL. ICE portal page, you can have either the guest or bring your own or hotspot, anything, any method is displayed to the user. That basically would be completely in control, right, of security team as in how they want these guests, you know, to access the network. And this is where you can design basically for, the ICE portal page for the bring your own device, for the guest, right, for the user I'm talking about, their hotspot and etc. User authenticates. Now, how would user authenticate actually? Whether they are sponsored before itself, they have got the all credentials, details so via email or SMS, or maybe they self-register, right? Created account and then the credentials actually gets delivered to the user. Sponsor approval again, or maybe certificate provisioning. And then finally, ICE applies a new authorization profile, right? Which basically access device updates session permissions. Like internet access you will have, or you will have the corporate access, right? So that basically is again defined under the authorization profile as in what you are supposed to do, where you are supposed to connect to, right? So I have actually put these bits and pieces like the configuration part, right,
Yeah.
separately. And then I'll just will basically discuss about it. So as you see here, this is basically the configuration part here, right? In
Mhm.
order to configure, right, or in order to let's say authenticate this guest machine, right? There are 7 actually steps or the configuration parameters that you need to go through, right? The first is basically network device configuration, which is NAD, right? Switch or wireless controller must be added in ICE under network devices. And then radius is configured, shared key and device profile is configured, which we have already done it, right? Ensure radius change of authorization is enabled. That we would see whether this change of authorization is enabled or not, right? Second, AAA configuration is in place. NAD, right, configs to and points to ICE as the radius server, right? And then enable 802.1x or map as authentication methods on access ports. So here, what exactly happens when, so if you talk about again, like map and 802.1x, right? Let's say this is a test machine and it wants to get connected to the network. So what exactly happens here? Or I would say the session itself, right? How the session is initiated and all, isn't it? So
Yeah.
what exactly happens? A particular client, right, which is a guest, or in this case, let's say this machine, as soon as you log in, though either you are configured, let's say, for authentication as an MAB authentication or .1x. Let's say MAB authentication and then followed by the .1x authentication. Okay. What do you think? What should happen if the MAB authentication and the .1x authentication both, are rejected? Then ultimately this test machine won't be able to connect to the network, right? They either,
So,
if it is whitelisted already, if this test machine is whitelisted already, then this machine would get authenticated either via the MAB or .1x and then finally added to the network. But if this test machine or if this user, let's say a guest user, anything, right, comes to the net, connects to the network, and it should not happen where the guest machine should get rejected and then nothing should happen, right? Otherwise, this guest user won't be able to even connect to the network. So what happens when the guest machine sends, let's say, initial MAB authentication or .1 authentication? There we have an option, instead of rejecting, you continue the process. Let me see if I should have basically, but then 192, it is 113, right? Yeah. Let me log into ISE. So where it is defined basically whether the particular user or the machine should be allowed or rejected, that's basically the policy sets, right? Under the policy sets. When you click on the policy sets, you have the default policy sets here. And when you click on this, right, that's basically the authentication policy. Now, you see here, you have the options, right? Let's say MAB or .1x, you have options here. So when you click on option, if authentication fail, reject. If users not found, right, then continue. Do you see that? So in this case, what is happening? I hope you are able to see this ICE login, right?
yes, I do.
Right.
I'm
S-
following.
Yeah. So if user not found, right, it should continue. And in our case, what is happening in case of guest machine, right? It is not like the authentication is failing, but this basically guest machine or the user machine is not even available, right? Not found in this database, isn't it? So if it is not found, then continue. Continue means this is where it will further continue, you know, for the web authentication. If here itself, if I say that reject, if I say, let's say reject, then this user would not even, you know, that the web authentication would not be processed because this is rejected. So this is where this is important parameter. We have to, instead of configuring reject, we would configure, which is by default, by the way, continue here, right? So continue means if MAV authentication fails, if same goes to the .1x also, you can also select for the .1x, you have option, and then you see here, you have user not found, maybe you can select continue, right? If so, the map failed. If the map failed, this is where this basically knows that, okay, I have to go for the web authentication, right? And this is where basically it will, because the core I switch here, what core switch does, it basically sends the limited ACL. Limited ACL will have only access, right, to the ICE. Once the traffic goes to the ICE, ICE present the portal page what we have discussed earlier. Guest basically machine, the guest user actually authenticates or creates the account and then self-registers and all that process takes place. When finally it is authenticated, this is where the core switch or the ICE, in fact, ICE would actually download the ACL, which is downloadable ACL, what we call it, downloadable DACL, downloadable ACL, which is here. So if I go to the, you know, the administration and maybe so what we're talking about here is the guest access, right? For the guest access, this is where you have the, so if I go to the overview, yeah, yeah, this card and all identities, right? You have identity groups, you have administration. So let me just close this, right? You have portal and components. If you see here under the portal and components, this is what I was talking about. You have guest types. You can create sponsor groups, sponsor portals, right? So if I click on the guest types, they are our guest types, whether they are contractor or daily, right? We have social login or weekly default. So these are the different actually the guest types you have. So if I go to the manage account policy set. So if I go to um, let's say policy element, not policy element, but then would it be setting? Um, the custom fields. Okay, hold on. First of all, let me see what we are doing here, right? What we're talking about. So we were talking about the DACL and all, right? So you have to create the, I mean, the downloadable basically access list. That's what we were talking about, right? What is that ACL? We need to create that ACL, okay, and assign to the profile so that the ICE should, you know, as soon as the authentication happens, ICE should, set or push the downloadable access list with the further accesses and what all you are now after authentication you are supposed to authenticate. Now, key thing to here notice or point, to make a note of this guest machine. Once the session is created, even for the limited also, the session would remain up. Okay. Even on that session itself, this ICE would actually send the DACL where DACL with the other, open connections, whether you are, authorized to access internet or corporate network, right? That basically happens in the process of COA change, of authorization itself, within the COA itself, within the session itself. So it's not like it has, though it has initially limited access once, but even though the session is created and in addition, this ICE would say, hey, now you are authenticated and you are allowed to access internet. Okay. So that's basically called DACL. And I think we should have somewhere here. Um, Redirect ACL, you see, access control list. So created on the switch that basically redirect, to the ICE portal. And then under the authorization profile, you see here, web redirection authorization profile. This is where I would create under the ICE portal to, so basically we would create the DACL and then apply that DACL under the central web authentication redirect URL, right? And then finally, the post authentication profile, which grants full or limited access after successful login or successful authentication, right? Guest web authentication portal in ICE. This is what we were talking about here. So you see here, um, this is the portal, right? And then this is the guest portal. So you can create. So anyways, we would actually do this lab separately. I just don't want to mix two things here, but side by side, that is where I am also taking a reference, or I am also uh, you know walking you through the options, the different options as well. Okay, so okay, so let me just go back to the this, and we were talking about, okay, the next is basically the policy sets. Policy sets, as just now I told, right? Authentication and authorization. So basically we'll go to the policy sets, and then under that you have default policy already, right? And then we'll go ahead and create the policy set, say continue, right? You can create your own policy set here, or just above the default you can create one more, right? So that's something we will talk about that. And also the authorization policy, you know, the authorization policy, what exactly you want to for the local exception, or maybe for the global auth exception, right? You have, this is the default one that you have. You can create your own. So we'll talk about this in our next section, by the way, right? So, and then the certificate is basically, if so ICE usually should have, or must have, in fact, valid HTTPS certificate. That again, you can generate this certificate and then send it to this CA for the signing, and then you can install basically that certificate in the ICE. So that's something we have already done this part in our previous lecture, right? So
Sure, sure. Abhi.
yeah, that's
Rabi,
something.
just wanted to get my concept clear on DECL. Can you just brief me up on DECL once again?
Yeah, DACL is nothing but the access list. Access list, initially what we have seen in
Okay.
the switch, right?
Yes,
That
yes, yes.
switch will have a initial access list, which will only redirect the traffic from user traffic to the ICE initially.
Okay,
But once the authentication takes place, you would create one ACL in ICE also. That ACL would get kicked in when the user is authenticated successfully. This is where the ICE would send that access list to NAT device saying, hey, this user is authenticated and this is what it can access. Let them access the internet, or let them access to the corporate network, and etc. So ultimately,
yeah,
one ACL you would create here, and then one ACL you would create here. That the ACL that you create in ICE, that is called actually downloadable access control list. We call it actually DACL.
okay. And
Yeah.
that access list initial traffic or DACL, in other words, applies in ICE as well as in core switch, right? Or only it applies on ICE, the
Um,
DACL. Did I confuse you?
I didn't get that question.
No, you said that the DACL, or in other words, is initial traffic. It's access list which is initiated initially in the ICE, right?
Right.
To allow the NAT device to
See,
communicate, right? And then
right.
connect to internet, right?
So to answer this, see, this is where we have the already access list, downloadable ACLs in ICE. These are the default ACLs, okay?
Yeah.
So under the policy sets, and then under the results, you have this authorization. This is the DACL where I was talking about. If I click on, let's say, deny all IPv4 traffics, if I click on deny, so it says deny is reserved DACL and cannot be edited. That is okay. right? So there is already deny, and then you have also allow, permit all. These are the default. Okay, so
Yeah.
we would walk you through what all the access list. How would you how can you create? Simply you just go ahead and create, then give the name, and this is where you have to specify the access list
Okay.
as in what all it is allowed. Okay, so
That's
that's
right.
something.
Okay. So it will be in a URL form, right?
Yes.
Which you can add the access list, right? To allow the traffic to communicate via ICE.
So what happens basically? We would create the DACL here, one, and then allow HTTP, HTTPS traffic and all. Okay, and then this DACL you would apply it under the authorization profile. Once
Okay.
the authentication takes place here by between the user, guest user, and ICE, this is where the
ICE.
authorization policy profile would be pushed right
Yeah.
to it, and this is where this would have the internet access, because under the authorization profile you have the DACL also,
Yeah. That's right.
right?
Got it.
And finally, this particular user has the access,
Sure.
right? So yeah, that's something about how basically the web authentication works for the guest access. Our in next our next class we would talk about the lab part. Pretty much
Sure.
same topology we would keep, right?
Yeah. Sure.
And then we will